Hi folks, we're going to take a look at page 582, number 6. So here they give us this function and they want us to find the points where the slope of the tangent is equal to 0. So in other words, we have to determine where the derivative is equal to 0. And so step 1 is to determine the derivative of this function. Now I recognize this as being a function where we have a variable in both the base and the exponent of a power, which means we can't use our regular differentiation rules to determine the derivative. So we're going to use logarithmic differentiation. So instead of working with the function x to the 1 over x, we're going to work with the function ln of x to the 1 over x. All right. Now, why this is useful is because we can now rewrite this using the ski-slope rule by bringing the 1 over x in front, so turning it into a product. So 1 over x times ln x. All right, and we're going to take the derivative of both sides of this equation. Okay, and this will also give us an opportunity to review why logarithmic differentiation is useful. All right, so what we're going to do here is on the left-hand side, we're going to find the derivative using the chain rule because we've got the function of a function. And on the right-hand side, we're going to find the derivative using the product rule because we have the product of two basic functions. All right, and in using the product rule, the chain rule on the left, we're going to see why this is useful. So if I apply the chain rule, so that means this x to the 1 over x becomes my u. So the derivative of ln u is just 1 over u. So 1 over x to the 1 over x times the derivative of u with respect to x. But the derivative of u with respect to x is exactly the derivative that I'm trying to find. Okay, so that's why this is a useful process, because now I can just isolate for this expression. All right, on the other side, so again, I won't write it all out because we've done this a lot here. So we have x to the negative 1. Okay, that's how I'm going to consider 1 over x to the negative 1. So the derivative is negative 1 times x to the negative 2. And of course, x to the negative 2 is just 1 over x squared. All right, so as you become more comfortable taking these derivatives, you can skip the step and just simplify in your head. All right, so that's the derivative of the first function. Now we have to multiply by the second function and add to that the first function times the derivative of the second function, but the derivative of ln x is just 1 over x. All right, and now we can solve for the derivative that we were in fact looking for. All right, so I'm just going to multiply that to the other side, so x to the 1 over x. And here, let's simplify this a bit. So I'll put the positive term first. So we have 1 over x squared. Okay, and then here we have minus ln x over x squared. Okay, and what we have to do is determine when this derivative is equal to 0. Because remember, that's what we're looking for, is when the slope of the tangent to this function is equal to 0. So we just set the derivative of this function equal to 0. All right. Now we can reason out here that this first expression is never going to be equal to 0. So even if we could plug x equals 0 and try to figure out whether that's going to work, well, wait a minute, we have a 1 over 0 in the denominator, which gives us something that's undefined. In fact, we realize here that it was only defined for x strictly greater than 0. So what we have to worry about is when this factor in the bracket is equal to 0. But this, I think, we'll see is something fairly easy to solve. All right, so the first thing I'm going to do is multiply both sides by the lowest common denominator, which is just x squared. So if I multiply the left by x squared and the right by x squared, well, here this just becomes 1 minus, again, the x squareds cancel out, minus ln x equals 0. And I have something extremely easy to solve, which is just ln x is equal to 1. Okay, so I can either, reason out that ln of what number is equal to 1, what's going to be ln of e, okay, or I can, turn this into exponential form if I remember that that's base e. So what do we have? We have e to the 1 equals x. So in other words, x is equal to e. All right, but of course they're asking us for the points where this occurs. So we just need to take this x value and put it into the function. Okay, so here we have that y is equal to x to the 1 over x. So y is equal to e to the 1 over e. Okay, and so our answer here is that the point is going to be e, and e to the 1 over e. Okay, so let's recap. So in the end, this was just, a question we've answered many, many times with respect to the derivative of a function. We need to determine where the derivative is equal to 0. It just turned out that finding this derivative took a little bit more time. So remember, anytime you see a variable in both the base and the exponent of a power, you're not going to find the derivative explicitly. You're going to work with the natural logarithm of that function, and out of those steps will come the derivative that you're looking for. Okay, that's it for this one.